here is the last page of our notes, page 13. Now you're probably wondering what happened to page 11 and 12, and they are just information. So if you want to go back really fast, we can. Page 11 was just an addition of rotations and looking at how the points rotated following the things we talked about, like if we rotated one quadrant, so 90 degrees, then we switch the numbers and one of the signs. So that would apply to this one right here as well. So like see on this one, the numbers switched and then one of them is negative, whereas originally they were both positive. So down here we have the same idea on this point right here. So we would switch the numbers, but we would have a positive 1 and a negative 4, and then that rotates it the other direction. So numbers switched, one of the signs is negative. Now if we don't switch the numbers and both of them are negative, then we get our 180 degree rotation. Okay, and then at the bottom of that page is just some rules that we learned. There's nothing really to write, it's just some reminders on how it works. Then we have a summary. How to do translations, how to do rotations, how to do reflections, and now we're going to do dilations. Okay, so page 13 for dilations. A dilation is a similarity transformation. So instead of it being the same size, same shape, it's similar. Same shape, but different sizes. It changes the size of a figure with respect to a scale factor. Now we need, besides the scale factor, sometimes when we're doing this, we need to know where the center of dilation is. So we're going to call this center. So the center of dilation. And then you can see our original figure A, B, C, and see the lengths of our original figure. This length is 2 and that length is 3. And then this dilation created a new figure, A prime, B prime, C prime, with a side length 4 and a side length 6 that correspond to this one. So they're the same triangle shape, but two different sizes, and the sizes are proportional. So like 2 times 2 is 4, 3 times 2 is 6. So that's the scale factor would be 2. Oops. So scale factor, let's just write that down. Okay, so scale factor, we're going to call that K. When K is greater than 1, the dilation is an enlargement. It's going to get bigger. I don't know if you can read my handwriting, sorry. Maybe I'll go back and type it in just a second here. When K is between 0 and 1, in other words, we're never going to have a negative K value. When K is between 0 and 1, the dilation is a reduction. See, I can write carefully so you can read this. Enlarge. I don't know why I can't write the word enlargement without it looking weird. Okay, enlargement and reduction. Let's do a couple of examples here. So problem 1, we've got A to B is a length of 2, and A prime to B prime is a length of 4. B to C is 2, B prime to C prime is 4. So it looks like everything's doubling, right? So scale factor 2, identify the dilation. Well, from ABC to A prime, B prime, C prime, it's getting bigger, so that's an enlargement. Right? And then this one, our point of dilation is at point C. The entire distance to paperclip P is a length of 30, and then the distance to a paperclip P prime is a distance of 18. So this time we're doing a reduction because we're going from the large paperclip to the small one, and I can tell that because of the prime notation. Now to find the scale factor, we want our scale factor to be smaller than 1 because we're getting a reduction. So we have two numbers to relate to each other to create that. We have the 18 distance to point P prime, and we have the 30 distance to point P. So if we were to go 30 over 18, we would get a number bigger than 1, and that's not what we want. We want a number smaller than 1 so that we get a reduction. So to do that, we would have to go with 18 over 30, and then we should reduce it. So 18, 6 goes into 18 and 30. 6 goes into 18 3 times, and 6 goes into 35 times. So I think this is a 3/5 scale factor.